Welcome, ladies and gentlemen. What we're doing today is talking about a tool which is named Solver. Either you have it already installed or activated, then you'll find it under Data, where you find in the Analyze part the Solver, or you need to activate it. If you need to activate it, you'll find the options in the Register Card of File options, and there in the add-ins. For the add-ins, we are looking for the Excel add-ins and use the button of Go, and there you can add the Solver add-in, which is important. It is installed already, but it's not activated normally within the Excel installation. And then if you click OK, it should be available over here. Sorry. What we are looking at here is a tool which helps you optimizing the result of a typical function. We have here a typical option like we have three different products, we have different capacities, we have different production times, assembly times, and we have maximum sales and maximum margin incomes per product, and we want to optimize the income for the company. And that means that we need to calculate and try out, and we could do kind of a typical tryout where we say, well, let's produce 200 here and produce 400 here, and then we can't produce anymore because we don't have any rest capacity anymore. Or we could say, well, let's do only 300 here, and then we do have 200 of them, and we can play around with this. That might take quite a while and lead to different examples, but the typical solution here is 280,000 euro, and what we want to do is to optimize this by using the solver. The solver is a tool which you can activate, which is to be run on a cell with a formula. So the set objective cell needs to be a cell with a formula, and we can maximize, minimize the result of the formula, or we can bring it to an exact value by changing cells. So what we do here is, well, we say, well, the result of this formula should be maximized by changing those cells. So it's kind of a big brother of the goal seek, where we could say, well, this cell we bring to an exact value of by changing one cell, and here we have different variable cells. The problem is if we only do it like this, like tell it him, then he's using a mathematical solution, and then if we now say solve, you see that he's kind of solving the problem, and the result is quite large, but it doesn't make any sense because it's the workload is way too high, and he's simply increasing the numbers here because we didn't say what is allowed to happen and what is not allowed to happen, because the constraints are the important part for the solver. And that means we need to think about constraints, so what is allowed to be done and what is not allowed to be done. And so, for example, we could add here kind of the one constraint that the capacity always needs to be larger or equal than the workload. Or we could also at the same time give the rest capacity larger or equal 0, which is the same. And if we add one of those constraints, you see this is something that you can refer to. And in this version of Excel, there's a little option down here. The unconstrained variable are not allowed to be negative. That means those are not allowed to get negative. In the former Excel versions, this was not the case, and then he could use a mathematical trick. So he could use a production 1 by minus 5 million to get minus 5 million multiplied with 2 is minus 10 million, and then we have a capacity of 10 million plus 3,200 for the production of number 3. So he could use the mathematical trick here. So this is something you are coming along while not using this option here. Additionally, you have to think about additional options that you want to have. For example, what is allowed to happen. So if, for example, product 2 is dependent on product 1, we could say, well, there needs to be double the amount of product 2 than product 1. You're setting those constraints here. In another case, sometimes if you're producing, for example, cars, you may be selling 3.5 cars or producing 3.5 cars might be the optimum, but the selling of the zero point 0.5 car might be a little bit tricky. So for example, we could say, well, and those cells, please make sure that they are only integer, means no decimals. And if we activate this, then we go through it, and if we solve it now, you see now the solver proposes to produce 600 pieces of this, 500 pieces of this, and we come to quite a nice amount of 314,000, whereas our first try had 280,000. So it's quite a difference. Within the solver, please be aware you can try it out every time and simply restart the solver. Just at restarting, I would refer to the changeable cells to be changed back to 0 before running the solver, as if there is already some numbers inside, the result might be different. You see the options part here, and the options brings up a new option where you can constrain the exact amount, how many decimals should be looked at, what is the maximum time. Sometimes if you have different constraints, those interact with each other, which might result in the solver calculating and calculating, and then you need to perhaps preset how long is the maximum time Excel should calculate, or you know that you press the escape button double, so escape for stopping the solver, especially in the exam. For the solving method, there are three basic methods: the nonlinear, the simplex, and the evolutionary. I have to admit I never used the evolutionary up to now. In 95% of the cases I'm using the nonlinear one, simplex quite rare. There is an explanation, and the explanation normally says if the formula in the objective cell put to a chart gives a straight line rather than a curve, then you're using the simplex model. I'm really good in mathematics, but at most of the formulas I don't see if this is getting a straight line or if it's getting a curve. So I can only recommend use the non-linear version, and if you're very sure about the constraints and the non-linear version doesn't come up with a proper solution, try the simplex once and switch between the two from time to time is my typical way of dealing with it. Still, always when you are solving it here, please be aware this is just a suggestion. That means the solver comes up with a suggestion depending on the constraints, and not only on the constraints but on the order of constraints. The order of constraints is important because it goes through the constraints from the top to the bottom, and that might be a change if you change the order of them. So you have to try it out. Good. The solver itself is set to the sheet. That means if you have another sheet and you start the solver, it is empty. And if you go back to your original one and start the solver, you see the solver is still there with all the sets. That means you can always close the solver, do something, come back to the solver, and then you will find all your settings in there saved. Good. Thanks for your attention. See you again next time.